We're standing at the corner of 105th Avenue and 105th Street. This is where we're installing the in-street embedded track up the center of 105th Street as part of the North LRT extension from downtown to Nate. There's lots happening on site, including tunneling, roadwork, and station construction. But one of the most interesting and perhaps most important activities in 2012 is the installation of the track system that will eventually carry thousands of commuters a day along this LRT extension. In total on the new line, each track is about 3.5 kilometers long when you include all the tie-ins and special track work done at Churchill Station, as well as the tail track at Health Sciences Station. The tail track is required so that trains from Nate can travel through the existing LRT tunnels, down to the University and Health Sciences stations, and then turn around and head back north to Nate.
The reason it takes so long to build a track is because everything that we do basically from the start of the project is centered around trying to give a quality installation of the rail. We install the rail to very, very tight tolerances that are less than a millimeter in all aspects, both in vertical and horizontal alignment. Typically, the length of time it takes to construct the track bed and install the track is between 1 year and 2 years.
We're using 3 different types of track structure on the North LRT to Nate. Tie-in ballast, which is kind of the traditional railway style of rock ballast with concrete ties and then the rail. Embedded track, which is in-street rail where the rail gets set into the concrete. And then direct fixation, where the rail sits on a concrete slab up above the top of the base slab. We select the appropriate track type for the location. So for example, on the tail track, because it's tie-in ballast there already, we're matching in with the existing and using tie-in ballast. Through the extension up to Nate, we're using embedded track and direct fixation as more urban styles to blend in with the neighborhood a little bit more, as well as meet some of the life cycle and durability requirements for the LRT.
On this project, we were able to work through the winter by using large hoarding structures. These hoarding structures are garage-like in appearance. Inside these structures, the temperature is kept above zero, which allowed us to pour our concrete safely and allow the concrete to harden before it froze. The hoardings doubled as the means of moving our track work, formwork ahead with us.
The rail is laid basically in individual segments. It's laid down and then the next section is put in and they're welded together. That weld becomes a seamless joint so that we don't get the clickety-clack. After the rail is laid, there's a number of steps that happen before we can actually use the track. So the rail is stressed at a certain temperature so that it will allow expansion and contraction of the rail. And then finally, the remainder of the systems are installed, such as the traction power and catenary system, which provides power to the trains, the signaling and communications, and then we're ready to run trains on the new rail. We'd like to thank the local residents for their patience during construction of this project. We know that it's disruptive in the short term, and we know the public understands that there's a huge long-term benefit to the city as a whole and to these local communities of this LRT extension.